This is a Google Colab notebook, which is a Jupyter environment that allows me to write and run Python scripts using Google Drive. In this notebook, I've written some brief code to take an image of an iris and determine the most frequent colors represented. First, I'm going to load all the libraries I need for this experiment. These are sort of generic libraries and import statements. And I like to include a print statement where there isn't already an output. Next, here's an extreme close-up of an eye that I've taken from the Encyclopedia Britannica. Oh, I have to upload it here, I guess. So let me upload my images. All right, now this should load. All right, there it is. So to keep this experiment simple, I don't want to include these colors like the whites of the eyes or the skin or the eyelashes. So I've manually removed this using Adobe Photoshop and painted over all of that in black so that we can tell our code to ignore the black and only take into consideration the colors that are in the iris. Now I have experimented with the upper and lower thresholds for each sum of the pixels RGB values. This will remove extremely dark and extremely light values from the color data in consideration. I check the thresholds by comparing the original output image, which will be on the left, and the image with the parts removed marked out in red on the right here. So this looks okay to me. If there were parts of this image being blocked out that I didn't want to, I could adjust the threshold. Right now, my lower threshold is 0.1, meaning that the sum of the RGB values, each one being from 0 to 1, if it's below 0.1, it's removed, or if it's above 2.9, it is also removed. So again, having found these satisfactory threshold values, I can set them below. Here, the lower threshold, the darkest value, and the highest threshold. The next functions that I will run first count the number of pixels to be included in the analysis, so the number of colored pixels in this image. Then it formats that color data as an array of RGB arrays. I could have just left this as the original image, but I thought it was nice to format it because it keeps it in a nice format for if I wanted to export it and use it for something else. Then this function runs the k-means algorithm on the color data to find the n most significant colors by clustering the data. There are a couple ways you could define that, but I can talk about k-means later. Basically, it means it's going to look for the different color groups. This function prints the RGB color values. And finally, this code prints the most common colors, and it will generate a link to the TinEye multicolor search engine results for images with similar colors to the original iris. So the way it does this is it will print the values found using the k-means algorithm. It will find the 16 most common color clusters, and then it will generate a link to the TinEye multicolor search engine, which I did not create, but it's a really nifty search engine where you can put in up to 5 different colors in hex. So I have that code right here, and then you can weight them according to how much that color shows up. So I've generated the URL here using a k-means where k equals 5, and I will generate that now. This usually takes a minute to load, so I'll go through and make sure I've run all these. Check, check, check. All right, everything looks good. Let's see if anything's printing, still loading. I could also change these values to different Ks and generate as many color clusters as I wanted to. Here's the result. So here's the original image, the original iris, and then these are the colors that the algorithm pulled out. So you can see that there's this color, which might be these streaks here. Then there are the darker gray values that might be from around the edge, maybe the influence of the eyelashes. And then of course, all the blues you would expect. And we can go to this link, which I've generated. And this is the image results from TinEye. So these are images from Flickr that most match the colors found in this iris. So things like the ocean, looks like a chalkboard, graffiti on a bridge. Pretty cool.